All right, we have the next lesson, which is solving systems by substitution. So this is another way to solve a system instead of graphing two lines to find the intersection. And just like with when we graphed, you have the three different types of solutions, except instead of graphing now, we're gonna do it more algebraically. So you're gonna have the same three types, right? All real solutions. With graphing, that's when they were overlapped. But when we are solving with substitution, it's the variables cancel and you're left with something true. No solution, so on a graph, that was when it was parallel. But for systems, the variables are going to cancel and you are left with something false. And then the last one here is one solution again, where we're looking for that x value and y value. So in this one, the variables don't cancel, so it's still there, but you're going to solve for x's number and for y's number. So we got some examples. I got a level 1 question that everybody seems to enjoy, but also gets it wrong at the same time. So it's when you're given one number. All right, so we got y equals -9, 12x plus 11y equals 33. Well, I see this y is equal to this stuff of -9. So in my other equation, I'm going to replace that y with our stuff. So just like yesterday or the previous lesson, it's 12x plus 11. Now again, instead of that y, we will put the -9, so parentheses -9, equals 33. And then we just go forth and we solve. So I'm going to zoom this up. We got to distribute, so this is 12x minus 99 equals 33. We add that constant on both sides. These eliminate. 12x equals 132. We divide by 12 on both sides. We get x equals 11. All right. So I got x's number. It's 11. And here's the thing. We already know y's number. Y's number is -9. So that means our solution, wrote as an ordered pair, is this 11, comma, the -9 that we were given for that y value. So this is one of those nice ones. There's not an extra step to it. We will do it again. All right. So we have this equation here. My bottom is a number set equal to some stuff. Okay. So that means I'm going to replace this x in the other equation. So I have 5. And again, instead of that x here, I'm going to put, what we got? We got 8. And then we have this plus 5y equals 20. So once again, we replace the x with the 8 that we had. We only have that y here, which is good. So now we can solve. Distribute, we get 40. Subtract that constant on both sides. Divide away that coefficient. And you get -4. So I'm going to actually put this in a color here. So we figured out y's number is -4. So that tells us that we're going to have a solution. It's going to have x and y. We know our y, it's this -4 here. We need to figure out our x. Well, what's nice is we already know x's number. It was given to us already. So our answer is 8, -4. There we go. So this is how you handle when you are given a number. Sometimes you'll be given that y, sometimes you might be given that x, but you were given it, and that's okay. Now we know how to do it. You've probably done this before and just didn't realize you were doing it. It wasn't called a system, but now we are. So here it is. There you go. All right. Now we're going to go through and we're going to do sums where there's no given numbers. So we got this equation right here. If you need to pause to write it down, that's totally fine. But I see at the top we have y equals this stuff, okay? So that means in my other equation, I'm going to replace the y here with that stuff. So let's do it. I am going to bring it over. So I got this 9x, that stays the same, plus 3. Here's where my y is, so this is where my things change. Instead of a y, I'm going to put that 4x minus 6, I'm going to substitute it in, equals negative 18. Okay, so the only difference between here and here is instead of a y, we put that stuff in its place. So my y is gone, and now I only have x's left. So when I have only x's left, that means I can do some solving. So I got some distributing I can do. And this gives me 9x plus 12x minus 18 equals minus 18. I got some like terms going on here. 9x and 12x together make 21x. Bring down the minus 18. Okay. I'm going to add that constant on both sides. This gives me 21x. And this eliminated, right? And we didn't have to write 0 because we still had a piece here that we could bring down. But on this side, these eliminate too, but there's nothing left, so I do have to put a 0. I divide 21, and I get x equals 0. So I got my first number. I got x equals 0. I'm going to try and use a brighter color than what we have going on here. I got this 0. Now, I know x's number, so what I'm going to do is I'm going to kind of write my solution over to the side here. So, we got x, we got y. We know x's number is 0, and that's super great for us. That's half of the problem. What I don't know is I don't know my y's number yet. That's the other variable. So what I'm going to do is I'm going to look back at these original two. It does not matter which one you pick, okay? If you pick the bottom, that's great. You're going to get the same thing. If you pick the top, that's great. You're going to get the same thing. So what I'm going to do now is I am going to bring this friend down. And the reason why I'm bringing this top one down is if I'm looking for my y, this already says y equals. So what I'm going to do is just bring down. So I got y equals 4x minus 6. All right, I'm going to bring it down, and now I'm going to substitute again. I'm going to take that x and substitute it right where that other x is. All right, just like we did with the y's earlier, but now we have a number. We got y equals 4, and then instead of that x, I'm going to put that 0 we found, minus 6. Okay? And I'm going to do some mental math. You could totally type this in your calculator, but let's distribute. 4 times 0 is 0, so now we have 0 minus 6. 0 minus 6 is negative 6. So boom shakalaka, there is my y. And now I know y's number, which means I know my whole solution. So this is my super final answer right here. Okay? If I was to graph this, it would be at this same point. All right, this is a different way instead of graphing. I personally, I hate graphing because I feel like it takes longer to graph than it does for me to do this. That's a me thing though. Let's look at this next one here. We got this equation set up, and I see that I have this x equals this stuff. So that means that I'm going to take this x and I'm going to replace it with that stuff. So I'm going to take this over, and I'm going to rewrite it. It starts with negative 6. I'm going to get rid of this x with minus 6y plus 9, right? That's what I'm subbing in. I got minus 12y, that stays, equals negative 30. Okay, so all of that stays. The only thing that changed was this x, and now it's that stuff. that it says up here that x equals. So I'm going to do my math. Distribute, so this gives me 36y minus 54 minus 12y equals negative 30. Okay, I see some like terms going on here. So I see 36y minus 12y. So I'll put it on the side here in case you're not sure. Sometimes you can just take the like terms that are on the same side and write them to the side here to help you like visualize what math you're supposed to do. So if this is 36 minus 12y, that's what I'm doing. I'm not changing anything. It's all on the same side, so nothing changes. So this gives me 24y minus 54 equals negative 30. Add my constant on both sides because you always get rid of your constant first. These eliminate. We're left with 24y equals 24. Divide away my coefficient of 24 and I get y equals 0. So y equals 0 is the first number I found. Okay, now I'm not done, right? Because my solution, right? If I know one number, I have to be able to figure out the other. So my solution is going to be x, y. I found my y. It's 0. I need to figure out my x. So it doesn't matter. We're going to go back to the original. It doesn't matter which one you use. Okay, choose the one that's best for you. But if I know I need to figure out x, I'm going to choose the equation that already kind of says x equals. I'm going to bring this down. Okay. And what I'm going to do is I'm going to substitute in for this y. I know that this y equals 9. So I'm going to take this, rewrite it. I got x equals negative 6. Now instead of this y, I'm going to put a 0. And I don't write it like this. It's not 60. Okay. It's negative 6 times y. So I got to put it as negative 6 times 0 plus 9. Distribute. Negative 6 times 0 is 0. 0 plus 9 is 9. So, I'm going to write this in color. So, I know x's number is 9. So that means my final answer is 9, 0. Okay? Let's look at this next one here. I see this equation. At the bottom, I see another x that equals some stuff. So that means I'm going to replace the x in the other equation. So if I know this equals this, then up here I'm going to put stuff in. So I got, bring it over. Negative 2 still stays. This x becomes the stuff. So I'm going to put a parentheses. 3y minus 11. And then we got plus 6y equals 22. X got replaced. There's only y's going on here. So I can distribute. This is negative 6y plus 22. And then everything else gets brought down. I got, I'm going to erase this. I got some like terms here. I got negative 6y and 6y. Now when I write this to the side, right, that equals 0y, okay? But we don't write 0y. That looks silly. That's gross. So instead, this cancels out, okay? And what we're left with is 22 equals 22. Once again, you don't have to write a 0 like when we eliminate up here. These technically make 0, but you don't see us writing plus 0. We just cancel it out and bring what we still got going on, okay? And then earlier, and the problem before that, these ones canceled out too, right? But there was nothing for us to bring down, and we can't just leave it blank, so that's why we wrote the 0 this time, okay? So when there is other items, you don't have to write the 0. But when there's literally nothing left, you have to put the 0 down. So in this case that we're on, right, I am left with 22 equals 22, and that is true. Okay? My variables canceled. I'm left with something true, so my final answer is all real solutions. Okay? That is your answer. Okay? And again, this extra bit is just so you understand why. This is only the answer because the variables canceled, right? They canceled out, and 22 equals 22 was true, or is true, right? This is true. So we're left with variables canceled, we have something true. And that is the criteria that we wrote out that we needed for something to be considered all real solutions. Okay, so remember next. Oops. All right, so we got this next one here. My variable is y that equals some stuff. So I'm going to replace this y. Okay, so I'm going to replace into here. So I'm going to work this out. I'm going to walk it through slow and steady. We got 4x minus, and then now comes my y. And that's going to be 4x minus 8. Oh, I'm sorry, plus 8 equals 6. I replaced my y. There's no more y here. X's are left. Bring it down. All right. I got that invisible 1 going on, so I'm going to distribute it. So this gives me negative 4x minus 8. Everything else gets dropped down. Combine like terms. Uh-oh. All right. So these like terms, right? We got 4x minus 4x, and that equals 0x. Ew. We don't write that. Okay? They just cancel out. And what we're left with is negative 8 equals 6. Well, that isn't necessarily true, right? This is false. Right? We're left with a false statement. So, this time, our answer is no solution. All right. And I'm going to write the reason. You don't have to when you're solving, right? But the reason is because the variables cancel, and, right, negative 8 equals 6 is false. That is why it doesn't work out. That is why we can say no solution, because in the prior problem, the variables canceled and it was true. But this time the variables canceled and we were left with something that was false. So that's the difference between an all real number and a no solution. And if we graphed this, like if you type this into a Desmos, the graphs will be running parallel to each other. So that's your another indicator. All right, in this problem, right, my variable x equals this stuff here. So that means I'm going to replace this x with that stuff. So I'm going to start writing it out. I'm going to bring it over. We got negative 2, and instead of that x, we put 5y plus 3. Then we always have, then we will have 12y equals negative 6. I replaced my x. It is gone. That's the goal. There's only y's left, so that means I can solve. Distribute. We got negative 10y minus 6. Bring down your plus 12y and your minus 6. All right, here we got like terms. They don't cancel. That's good, right? And just remember, you can kind of write it to the side for your like terms, right? So I'm doing negative 10 plus 12. Now, this gives me 2y minus 6. Bring down that minus 6. Okay. Add 6 on both sides. These cancel out. We're left with 2y. These also cancel out, but we can't leave it blank, so we're going to put a 0. And right here, people go, oh my gosh, it's also a no solution because we're left with something false. That is not the case because we still have a variable. The variables didn't cancel. It's still right there. I see my y. It didn't go nowhere yet. So I can divide 2 and we get y's number is 0. Okay, that's okay. We can have that. So now I'm going to take one of my equations, and I've done the easy one both times. I'm going to do the more difficult one. All right, I'm going to reuse this one. Negative 2x plus 12y equals negative 6. All right. So I'm going to rewrite this, and instead of y, we are going to put a 0 for this right here. Right, I'm taking this friend and putting it here. This gives me negative 2x plus 0 equals negative 6. Some people like to do this, and that's totally fine. If this makes your heart happy and makes you feel secure in your math knowledge, totally fine to do what I had just done. And we get y equals, x equals 3. So our solution, right, our final answer, has to be wrote like an ordered pair, because technically you could graph this, is 3, comma, 0. Okay, so you still got the same thing. Now, I want to show you something real quick. What happens, so I used the more difficult one, but if I use this one, right, this is just like this is a side note, okay? Let's say I took the easier one, and you're like, nah, they can't be the same. I'm going to show you. X equals 5, and instead of a y, remember we had that 0, plus 3. I distribute 5 times 0 is 0, so I got 0 plus 3. 0 plus 3 is 3. We ended up getting the same thing. So it doesn't matter which one you choose, as long as you do the math properly in the orders and steps that we've done, you will still find success, whether you use the more difficult equation or if you use the easier equation. It doesn't matter. Your math is going to math. All right, last one, best one. Here we go. This is going to be fast. Y equals this stuff. Okay? If you want to pause to see if you can do this, absolutely, at any point. I'm going to bring this over because I know I'm going to replace this y. So I got that 3x minus 3, but instead of y, x plus 8 still equals negative 24. Y is gone, replaced, distribute now. 3x minus 24 equals minus 24. I combine like terms. I see that they would actually make 0, so I'm going to cancel them out. I'm just left with negative 24 equals negative 24. This is something true. And if I'm left with something true and all my variables cancel out, my actual answer is all real solutions. Okay, variables canceled, and we're left with something true. You can always watch and rewatch this video. I'm pretty sure I only did that many problems. Let me double check. Yep, that was it. Have a good day.